So most of the existing 3D environments that we have today, if not all of them, are currently set up as closed walled garden systems to a certain degree. They're not built in the way that we're prescribing with our white paper, in that they would be accessible the same way that a browser today can access the almost billions of websites. The numbers in the hundreds of millions for sure. It's probably approaching billions. So if we were to pick any one platform, while an individual platform might exhibit 3D qualities, being able to move around a three-dimensional space, that is not what we're necessarily trying to define as a metaverse. And so the white paper focuses primarily on the three tenets that we set out, which are kind of visible and are highly visible in the hyper reality video that we posted up there. And that is that all the applications that inhabit the metaverse or the spatial internet specifically are spatially aware, delivered on demand, and unbounded by application boxes. So in talking after we've released a white paper and gotten some feedback from people, it seems like the number one thing that either has eluded them or set off major light bulbs in the people that we've talked to is this notion that what we're really proposing is dozens, if not hundreds, of services all occupying the same space at the same time. And from the ground up, I don't believe Mozilla Hubs or any other platform for that matter is really architected or designed to host other people's services plugged into the virtual world. Feel free to correct me if I'm wrong, but that is the nature of what we're proposing, and that is that you can have independent developers build services and drop them into a three-dimensional space, that each of these services are spatially aware, delivered on demand, and unbounded by boxes. And it is the metaverse browser specifically architected uniquely to house hundreds of services at the same time, all sharing the same space. That's what we're proposing. So I don't believe that would work with Mozilla or Roblox or Fortnite or any other type of 3D world going on right now. And truth be told, RP1 can't quite do it yet either. We're working towards that. We're working towards making the browser be able to do that, and that is several months away. But once we get that, I think that will be quite the eye opener and the differentiator between
So,
hubs, other platforms, and what we're building.
and so let me give just an example of kind of what Dean just spoke about. If you were, let's say, in a virtual world and I have my own space, and I now want to play a game of chess with a friend, well, I don't know how to make the game of chess. My friend doesn't know how to, build the game of chess, and most likely, the platform that I'm using doesn't have a game of chess for me. And so the question is how do you enable an unlimited amount of people that want to build the game of chess, which could be a service that they can run on their own servers, and I'm able to use or point to that service and use it in my space, so that now when we walk up to that chessboard, me and my friend can now play that game of chess running off of someone else's servers. And for that to be possible, just for one of those services to be possible, you have to think about how do you inject those services in real time. More importantly, how does someone that builds the game of chess inject or make that service available to someone to use? And then to take it even a step further, how would I then have multiple services? So maybe I have a home front where I have an NPC character that greets you. That could be running off of, again, one of many different NPC companies that are experts in building NPCs. And I can have that service. And then as I walk into the house, then I have a chessboard, I have other things that are working. And that's just in virtual worlds. Now imagine that in the real world using your AR glasses, how can I have all these different services ran by third-party companies running in real time in my AR glasses? And so those are a very different way of looking at things. And in fact, I'm hoping that it'll be very exciting to most people that are hearing about this because, I don't know about you, but I've been in virtual worlds for quite some time, and they're great for, you get to meet someone, you get to look at some art on the wall, but how do you enable it to make it really easy to do things inside the metaverse? Not only for gaming or social environments, but also from a work standpoint or commerce to make it all seamless. And you're going to need many services that will be anywhere from a chessboard to a pool table, all the way to payments, to weather information, to an unlimited amount of services that we built by an unlimited amount of people all over the world. And you're going to have to build standards to make that whole ecosystem work. So anyway, let's go on to the next question. Looks like Siffer, you had another great question. Could RP1 run on a decentralized distributed GPU server?
I'll take that one too.
Go for it.
So theoretically, yes. And since this is an AMA about the white paper, I will tie it into the white paper, and I'll come around and re-answer that question towards the end. So what we're really proposing is the ability for anyone to run an RP1 like set of servers, which we call a spatial fabric. So what we're building, in addition to making a prototype browser, we're also making our first spatial fabric that would be put into the browser. At some point, we will be working with either other open source teams or companies, or we'll fund it ourselves to make an RP1 compatible service that is open source. But it would certainly be possible for someone to build a decentralized distributed server. It doesn't necessarily have to run on a GPU. It could, or GPUs could certainly be part of it. So if you were to be clever enough to build such a network, and people could just throw nodes onto the network, and that formed the basis of a fabric, then by all means, that certainly would be possible. I'm not going to say that that's going to be easy. However, RP1 is technically a distributed GPU-like server. We do incorporate GPUs in our processing, and we use CPUs equally, and we do distribute the load across a variety of computers that are networked. Right now, we've got access to about 40 servers to play with. We would expect that number to grow substantially larger. So it takes us about 30 plus computers to get to 100,000 people. Depending on how it gets architected, there's no guarantee that another network would achieve the same scalability. But yes, I mean, that would be really, really quite interesting to see an architecture that allowed people to just put up a node, potentially get paid for running that node somehow. And every node that just contributes to the fabric will add scalability to that fabric. That would be a terrific, amazing open source project that I think we would be, if we had access to funds, I think we would be willing to contribute towards that. So yes, it could. RP1 specifically, though, probably won't. Ours would be on a centralized set of servers that will be distributed around the world. We would envision around 400 computers per what we call a hub that support about 1 million people, and then we'd have as many hubs around the world as we would need. So it takes a lot of hardware, and it takes a lot of throughput. I will add one more thing in here, which is that in order to get this to work quite well in real time, the timing is critical. So when we set up our networks, we're talking about very, 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 very specialized co-location facilities with extremely large amounts of bandwidth that might be specially designed to connect between different hubs in the world. So if you just threw a bunch of random servers all over the world, it probably isn't going to scale very well. So yes, theoretically it could, Spatial Fabric could, but in reality it probably wouldn't scale or be performant enough. I will say one more thing, and then I'll let it go, which is that the whole point of what you get when you have a spatial fabric and when you're building services for browsers, that all the different services, the chessboard that Sean just mentioned, or something that tracks airplanes in the sky, or something used for healthcare, or something used for warehousing, or games, all these different components would reside all over the world and would be run by completely different companies. So if you wanted to build a particular service that performed a particular function, you could do so, run it on your computer, just like you would do it right now, and just drop it into a spatial fabric. So in that regard, you would end up with what we call a distributed state network, DSN, where all these different components are involved in creating the state of the metaverse. And we're running the foundational layer, but everyone else is contributing the services. Virtual pets, board games, real-time shoot 'em up games, services for industry, for different cities, and things that control traffic and self-driving cars. All of these different components all drop into a spatial fabric and run distributed around the world. Whether or not they use GPUs, that's up to each individual service. That's all I have to say on that. Sean, you want to continue?
Oh, there we go. I was on mute for some reason. Thanks for that answer, Dean. And I think it's really important to realize, when we started this company, we started on a brand new paradigm of technology that allowed us to scale well beyond anything that we know of in the planet. And I think the original dream of the metaverse was that there was these millions, if not billions, of people roaming around, this massive ecosystem, and you can seamlessly walk or teleport and meet up with anyone and play a game, or do your job, or whatever the case may be. Is And again, a lot of people thought or believe that is decades away because the hardware is not capable of scaling to that vision. And I should say Dean is really the mastermind behind the server technology, created a new paradigm of servers that basically unlocks the CPU. And there's two levels of the scale. One is that what we can do on a single computer is, a massive multitude of what is possible today. And the second part of the scale is linking up as many computers together so they're all one sharded architecture, meaning everyone is connected in real time. And so the importance of this was great. But as we were building RP1, we realized really what we're building is the first metaverse browser where you can connect to an unlimited map size and connect to anyone in the world and share content. But it was much bigger than RP1. We realized that really what was necessary for the open metaverse is an open standard around a browser, and then as Dean mentioned, a spatial fabric. And so if you think a browser can view websites, the challenge in a metaverse is that you need audio, you need a map, a spatial map, you need potentially 6DoF for avatars. And so those are all the different types of services that would be in a spatial fabric. But it shouldn't be just about RP1. And so we need to create open standards around both a browser and a spatial fabric so that anyone can build these components. And we hope that over the next 5 years that there'll be many native browsers, metaverse browsers, that are built by different companies or individuals, and consumers can pick just like they do today versus Chrome or Edge or Safari. So that it's not just one company that controls the browser, and there's not just one company that controls the spatial fabric. And that the importance of this is really creating, again, the idea of the open metaverse, which we took time not just to build RP1, but really to put this white paper together, to bring the community together, to understand these concepts, and really, push a lot of these open standards forward, along with some of the tech that we're building out as well. And so that's why we did this white paper, and obviously are doing this AMA. It's not just about RP1, but it's more about how do we build an open ecosystem that mirrors, the World Wide Web, and the power, and kind of where everyone can kind of build in any capacity. But with that being said, let's go to the next question. So thank you for the comment, ID. It makes sense so far. Some people don't get it, but I appreciate your comments. Pixel Girl. So would I be able to take my World Hub NFT on chain and drop it into your fabric and still have it connected to the blockchain? I have many things running inside my world connected to on-chain ecom.
I'll answer that too. So
Go for it.
without knowing what your World Hub looks like, Generally speaking, I would say any service that you have, however it's built, would be able to drop into a spatial fabric so long as it conforms to the standards and protocols that are derived from this experiment that we're proposing here. So, for example, if one were to say, I have something, I've programmed something, and can I drop it into any website? And the answer is, well, if it's built in C++, it compiled, no. But if it's built in JavaScript, then yes, probably you could. So if you're going to program for the web, things have to be built with HTML, JavaScript, and CSS, discounting WASM for a moment. And so there will be specific protocols for how you build services. But once you build a service, according to this protocol, and once we have these these metaverse browsers and spatial fabrics, if the service matches the protocol and the standard, you would be able to drop it into any world, however your backend server works. So if your backend server is based on blockchain, then more power to you. Excellent, that will work just fine. So any way in which you want to run your service and keep track of your data or expose your APIs or features to your users will be acceptable so long as it is compliant with the standards for the spatial fabrics and for the metaverse browsers. So generally speaking, probably. We would hope.
Um, so I already have, Pisco has a follow-up question. So it says, I already have Mona, Spatial, Cyber, and Hyper, and would love to just keep one on-chain in your fabric. And you said the magic words. Thank you. And, I think, Pixel I think one of the things is a challenge, and it goes back to kind of the earlier discussion of a federated metaverse versus kind of the open metaverse. Getting assets that were built for precompiled installable applications, they have different constraints than the open metaverse will have or the open web. And so you have to make massive considerations on how do you build that ecosystem and what is compatible. And again, not RP1 making that choice. I think there are constraints from a technical standpoint that everyone will realize, and then build not only tools to help bring some of the worlds that you're talking about into potentially RP1, but more importantly, would you want to build it from scratch that's optimized for the open web? And it's a very different way of looking at things. And it's not that we're against working with other people. It's more about they're not building on a on-demand web content, and it's a very different solution and solve that we're looking towards.
Yeah, I will add and see if I can't help provide an analogy here to visualize what it is that we're proposing. And so if you think about cartoons and newspapers, to go back to some old school media, right now, when people build an app, it's more akin to building or starting up your own newspaper. And so when you build an app, you've got to get the app, you got to build the app from scratch, put it in a store, and convince people to download and install your app, which is kind of like getting people to buy, subscribe to, or read your newspaper. Inside the newspaper, you'll find cartoons. And so if you're a cartoonist, you don't want to have to create your own newspaper in order to publish your own cartoon and then get everyone to buy your newspaper to read your cartoon. So what you do is you create your cartoon and then you syndicate it across multiple newspapers. So some very popular cartoon like Peanuts can be found in hundreds, if not thousands, if not tens of thousands of newspapers around the world. And so when you're building for the metaverse, the concept would be is that when you build an application or activity, as we call it, that you're building that as a service to syndicate it in other people's spatial fabrics. You could build your own spatial fabric, but chances are you build this, you drop it into one or more spatial fabrics, and then that activity is accessible from it will be accessible by any metaverse browser, and you could drop it into any spatial fabric. So if you've got a service, something in mind, like building an AI pet dog or an AI pet cat, then you could build that service, but you don't have to get people to download your app or run specifically your app. That pet could live and inhabit any part of the world inside of a spatial fabric without being bound to a rectangle. And so that AI pet would be able to walk around with you, go wherever you go, or sit in your apartment or in your house, and would be like I said, unbounded by boxes, and also would be delivered on demand. So no one would need to install your pet. It just comes with the spatial fabric once you got your metaverse browser on.
Any other questions from the audience? And if you're unable to type, you're welcome to raise your hand and come up and ask it, on the stage. While we're waiting for other questions, I think the importance of what Dean is talking about and the idea of services is probably one of the biggest things that have been well received around the entire white paper. And again, it's an unlimited amount of services that eventually will be built for the metaverse. And there has to be the freedom to be able to build what you want and make it easy for consumers to get your content without an app store kind of getting in the way. And but for that to be possible, you have to design a new type of real-time API to standardize and make it possible for not only the individual building the service to know how to build the service to make it metaverse capable, but more importantly, how do you make it seamless for people to connect to it? And that's going to take an open standard to make that possible. And a part of the white paper, if some of you have read the details, we did introduce the idea of a model foundation. And the importance of a model foundation is really one of the first real-time APIs that I'm aware of in the industry. And this makes it in extremely seamless for someone to build a chessboard or an NPC character company or whatever service you can imagine, and have it instantly be able to be connected in these. And so, Dean, right now we don't have any questions. Maybe what you want to describe, like why you built the model and kind of what it does.
Sure. Yeah, the model foundations is predates our company's uh, adventure into the metaverse. But before I talk about it, if it's possible, using the hand feature, raise your hand. I'd like to see if who actually has read part of the white paper. If you could just throw your hand up, get an idea of 4, 5. Okay, and awesome, thank you. I got about maybe half of the people here. So there's a section in the white paper on model foundations, and this was invented for work that our company is doing before I ever put on a VR headset or heard the word metaverse or thought about anything related to this new paradigm that we believe the world is going to move into. And so model foundations is just a very easy way for the applications that our company was writing to connect over a network um, to a service. Our company's foundation or history dates back to products that were uh, real time, typically turn-based gaming, so not nearly as real time as say what we have in RP1 right now. But the point of model foundations is it allows you to build generically a real-time service or non-real-time service based on REST in a way that makes it extraordinarily easy to consume. The biggest advantage of it is it puts the onus of building the client-side interface on the service provider. So if you think about something like PayPal or any payment processor that has a REST API available to you right now, and as our white paper alludes, we found there's estimated to be about 200 million REST APIs on the internet right now. Each of those REST APIs has a set of documentation that goes with it, and it shows you how to access the REST API, what parameters to pass on the line. And this is a stateless, non-real-time protocol where you have to send information to a server and then you get a response and then you send more information and you wait for a response to come back. And so anyone who wants to consume, say PayPal, who wants to integrate PayPal into their product, has to get PayPal's documentation for their REST service or any other payment service provider, grab the documentation, and then spend a certain amount of time building a client-side interface that interfaces with their application. So if PayPal has 100,000 customers who are doing that, it's likely that all 100,000 customers are building almost exactly the same piece of code. And this would be true for just about any service. So if your REST service or other service is giving you, say, weather report, or if it's designed to give you information about sports scores, or whatever the case may be, anyone who's consuming a REST service through documentation and URL parameters is roughly going to build, all the clients are going to build roughly the exact same thing on their side. And so MVMF kind of forces the client, forces the service provider to build a client side, but in a very, very, very regulated way that makes it really, really easy to do so, such that no client really needs to build a client side interface anymore, which means that the service provider is free to pick and choose any protocol that they like. It could be REST underneath. It could be Socket.io if you want something real time. It could be a different protocol for RP1. We use a binary persistent real time protocol, which we call a database protocol, to ship information back and forth. So you could use any existing protocol, or you can create your own protocol layer. And then you create things called models. And so to gain access to a service through MVMF, all you need is a connection string, which is one line of code that initializes or instantiates a connection to a service through MVMF. And then you need to know which model you want to open. So if, let's say, go back to Sean's example of a chessboard, if you produced a chess service using MVMF, anyone who wants to use your chess service would connect to it with one line of code, and then would open up a chessboard with one more line of code. And then through that model, you could call standard methods that are the same. Every single model of every single service looks virtually identical. So you issue actions and you get events, and they all behave identical. You don't have to know how to talk to the service at all. You don't need to know anything about how to talk to a payment processor. All you have to do is open up a model, which is a standard class, works in any language, and voila, you're playing chess in just a couple lines of code. Or if it's a car, let's say you buy, it doesn't have to be a fancy Tesla, it could be an old Volkswagen, Toyota, an Audi, whatever. If all of these future metaverse services ship with the models, then once you have a model to a car, you can roll down the windows, you can check your gas, you could start your engine, turn on your heated seats, change the radio. And all that would be through a model, and you wouldn't have to know one thing about how to communicate with that particular model. When you get into real-time services specifically, this is why MVMF is so powerful and so important for the metaverse. The metaverse is going to be predominantly real-time. And virtually all the APIs that exist today for services are non-real time. When companies try to build real-time applications, they're, I'd like to say almost exclusively, but it's like 99%, 99.999% of the time, the company that produces the real-time application will also produce their real-time client, which will be bound to that server. So it's not really released as a service. So if you're going to build a chess application, the chess application will be bound to the chess client. What we're talking about is building a chess service that anyone can connect to, and anyone can build the user interface for, and that service can be dropped into a metaverse browser, into a spatial fabric. And so building real-time services, there's no accepted de facto standard for how to do that. And so MVMF makes it really easy, and really gives you a very, very good framework for building real-time services. because real-time service can get very complicated very quickly, and very quickly spiral out of control so badly that applications just won't scale at all. So by using NVMF and the real-time service libraries there, you stand a very good chance of building a fairly scalable service that can drop into a metaverse. And that right now, I still to this day don't know of any real-time services other than those that our company is producing. But is going to be a key property of the future of the metaverse, that all of these stateless, non-real-time services will, I don't want to say have to become real-time services, but will likely choose to become real-time services as the metaverse evolves over time. So,
So
yeah,
I have good news. I have good news to add to what Dean just shared. The whole model foundation and what Dean has produced is going to we're going to be sharing it as an open standard, an open source. And the goal is that the world can use this not just for the metaverse, but for any real-time API that will I hopefully solve some of the REST APIs that Dean described in his answering this question. I also wanted to, so that's a really important key. It is going to be open for anyone to use. And the second component is we were actually recently at um, AWE, which is one of the largest XR expos. And we actually demonstrated the model foundation at our booth. And the way we did that, which I think is really neat, we created an RP1 light, an actual physical light. So call it a lamp or just a light in our booth, a physical one. And we had 3 physical switches under the light. The first switch was a dimmer switch that controlled the light in the booth. We had a website with an actual RP1 light on the actual website. And the second switch could control and dim the light on and off on the website. And the third switch would control in VR. You would actually go into RP1 and there was an RP1 light, and you could actually use that real light switch, in our booth to control the light in VR. And that was all done using Dean's model foundation connecting to a home automation software and making it instantly metaverse capable. And the cool thing is not only could you control those 3 light switches, but there was 3 switches on the website and there were 3 actual switches inside the VR space. And so that means someone in VR in our booth going around RP1, they can actually toggle the light inside the actual booth, the actual real light. So you basically had the same 3 switches on the web, in VR, and in real life, and all of them can control each other simply using the model foundation. And the real cool thing was Yench is like, that's really cool. Can I use that model for something else? And Dean's like, sure. And Yench was instantly able to create a spacecraft inside of RP1 that with 2 sliders, you can lift the spaceship up and down, and you could turn the volume of the engine on and off with that same model. And so the whole idea is eventually these models will be used across the board in all industries and different services, including even like payments. And I know, Dean, maybe you can mention on how eventually people will collaborate on standards around these different models based on the industry that they do. Maybe you can just give a hint to that.
sure. And I'll even let me talk about that example. So what we produced is a service called a switch, and it models a light switch specifically. Switch you usually think of as on and off, but this particular switch is a dimming switch. And so the switch is about as simple as you could possibly imagine. This service gives you access to a value in between 0 and 1. That's it. The entire state of a particular switch is just a floating point number somewhere in the neighborhood of 0 to 1. So if you want your light to be 50% on, the value of the switch would be at 0.5. And it's a floating point number, so it's 12 different, or I remember what it was, 12 different decimal points, or 12 decimal points of precision there. So anything that you wanted to model based on a number between 0 or 1, you could use a switch. So what you do is you would just go grab one of these models that would be assigned to you. So let's say you end up with switch number 1, 2, 3, 4, 5. Then this switch is yours to use for your particular application. And then whatever application you tie to that switch, whenever that value is changed, everyone who has access to that model, which is based on proximity, in a spatial fabric would then see that value change in real time. So if you wanted to use a light, or if you wanted to use uh, something to indicate height, right? So you could turn a light on and off, as Sean was mentioning, or the height to indicate, which Yinch used to move the height of a spaceship in there. But we also used it for one other thing. We very quickly turned on a value for how far we wanted space, to a scaling factor for space. So we had an open demo when I showed this. It got a lot of ooh, ahs, and wows. And so what we did was we hooked up the dimmer switch, or the light switch, to the interplanetary distances. And so by bringing that number closer, let's say down to 0.1, it reduced the distance of the planets, by 90%. And so what happened was all the planets in the sky got real big all of a sudden. Everyone looked up and like, oh, and so you can see all the planets lined up and going around Earth. Actually, going on Earth. Earth was just spinning, but anything that you want to, you can hook up to this particular model. So models can be a lot more complicated. They don't have to just model one number. They can model the state of a chessboard, which keeps track of whose turn it is, where the pieces are, which pieces have already been captured, or it could be the state of anything that's arbitrarily complex, like the state of a football game. Currently, it's second quarter, 4 minutes to go. Here's the current play that's running. Here are the stats of the game, anything like that. So all that can be embedded in a model, and it can update in real time. So in the case of payment processing, which is very consistent across multiple payment processors, so whether you're using a credit card or even something like cryptocurrency, a transaction usually is set up. It has a beginning and an endpoint when it's fulfilled. Potentially, it could be refunded. There might be some information, address information, whether it's a wallet address or actual physical business or home address. But you would have a model for payment. If you want to create a new payment, it would start in a initial state. You would fill in the information by sending in the actions, and then at some point the transaction would execute, and then later on you can go back, grab that same model, issue a refund if it supported refunds. And so if you have, let's say, PayPal or Stripe or Zelle or any number of online payment um, money exchange systems, they're all very, very, very similar. So what we would hope is that the banking industry will get together and standardize on a base class model that they would all build upon. So once if each of these payment processors are all founded on the same base class, then they will look virtually identical to any application that wants to do payment processing. So if you know how to use one model for one company, you know how to use basically every model for payment processing across the board. Same thing with cars. Most cars have four wheels. Most cars have the ability to turn on heat or air conditioning. They have windows. They have a gas tank or a battery. They have a horn. And most of the controls in most cars share a lot in common. Not every car is identical, but if there's a base class for the automotive industry, and they can get together on their own, decide what that base class would be, then any individual manufacturer can build on top of it. And then once you have an application that knows how to use a model for one car, you pretty much know how to use that model for all cars. They're all going to look identical.
Cool. Thank you for that, Dean. Hopefully, that gives a lot of background. We've had a little bit of a chatter in the chat room, or the chat area. So, Roth, we'll definitely take a look at that. Roth put in a link to the Open AR Cloud, and he said there may be some things that share some of the technical ideas that we're sharing here as well, and that'd be great. I'm not sure if you know a lot of people in that space. I'm definitely I'll reach out to Neil Trevette and see if we can maybe get some intros and really share both our white paper and obviously when the Model Foundation, I think, would be absolutely huge for the idea of the Open AR Cloud. In fact, everything that we're touting actually helps solve the idea of an open AR cloud. in general purposes, right? So like an open map system. In fact, when you go into RP1, we created a digital twin of our solar system, including Earth, one-to-one scale. And the whole purpose of that is that you can have this contiguous map system that you can easily have anyone inject their own AR and VR applications based on proximity, so that if I'm walking near, let's say, a museum or the airport in the real world, they'd be able to place their AR app and instantly I'll be able to interact with it through the browser, which makes it extremely seamless for people to consume these different applications built by anybody. And I think that's a lot of what the Model Foundation will help make possible. Jens, thank you very much for posting a picture of the web interface for the switch. That's the example where you can actually control on a web page the booth light. The light that you're looking at on that picture, that RP1 light would go brighter and not as bright as you go plus or minus. And then you can actually control the same switch in VR. So if someone was in VR, someone on the web page can actually make the light go off or on, or dim it in between. And it just shows how easy it is to inject services. I do believe that the future eventually will connect to even just our house. When we walk into our house, you'll be able to look outside, to your pool and be able to see what the temperature is and be able to control it, just in a spatially aware application, either through your mobile device or eventually AR glasses. But then you may look over at the toaster or different things all over your house that you'll have access to, including a potential an AR TV and all that kind of stuff. So I think it's super important that if we envision kind of the same things, how do we get there through technologies? And I think that's the importance of this browser, where it makes it super seamless for anyone to connect to all these applications, both on proximity and also without having to install the app, which I think is a really big deal, making it super seamless and the least amount of friction for consumers to get into XR type applications. Um, so Wilson, you have a question. You said uploading a file of building to test and check the process. When can this be done?
Yeah,
And
way
then you
over.
followed that up with low poly
Good
and 3
job.
materials and
Yeah, for
GLB.
sure. Great
You
conversations.
can drop the file here to check. And I think Jens, you kind of answered it, but if you don't mind answering for everybody, that'd be great. If you want to unmute, I think you said you had some issues with potentially your voice. So let's see if it works or not.
Yeah, sure. Thanks, Wilson, for that question. We have a asset placement system which we use internally at the moment. It's still being streamlined. It's currently still quite manual, but if there's a thing that you have already prepared, then I can definitely test it out, check that it goes through what what the bottlenecks might be. But public uh, we won't have a public facing one for a little while, as we got a couple of things. Parts of the process might be publishable at some point, maybe in a few months' time. But at the moment, it's all managed by us, because the tools are still quite what's the word, back officey. So great. I'll get the file from you in DM.
Yeah, and we're just to know the phase of RP1. We are at prototype demo phase. Our first demo was really to show what we could do on a single server. And so if you look at the idea of having a massive amount of avatars sharing experiences together and being able to seamlessly move from different experiences, not worrying about which shard or where their data sits. That's a really, really, really hard problem to solve and an important one for the idea of the metaverse. And when RP1 first started out, we were able to show that what we could do on a single computer, which was upwards of about 4,000 people in a single shared space, all streaming in a browser, in a single, ecosystem. And that was all on one server. Just to give you an idea of what the rest of the industry can do, they're typically relegated to about 20 avatars or less. And that includes obviously fixed off and full spatial audio. And so you can see just with one server compared to what they can do on their own. Now, if you look at everyone else, they cannot go past that. They'd have to basically shard the experience, meaning create a whole replication of the system for the next 20 users. We wanted to show that we can add a multitude of computers together, servers together, and still be in the same shard. And so our system currently is capable, once completed, of 100,000 people using about roughly 30 servers. And we have enough bots that we've been upwards of about 10 to 20,000 people in a single ecosystem, all where you could literally handshake and talk to each and every single person. not worrying about that they sit in a different shard or instance of the experience. And that is really at the core a technology needed to make this whole idea of the metaverse possible. But I think that technology should be kind of our kind of a special spatial fabric. But what we're really working with the community is to help define how anyone can build their spatial fabric. It may not be as scalable as RP1, but you'll be able to run it on your own servers. So a great example of this is that your home, you may not want to put your map and your personal data, let's say in RP1, you may do that on a different spatial fabric. And so when someone walks into your house, as long as that spatial fabric is designed to work with the standards of a browser, I can easily walk in, to your house, and the same way you share your Wi-Fi password, you'll share your metaverse password, and I'll get access, if you allow me to your spatial fabric that runs your house. And now I'll get access to your TVs or your pool or your toaster or anything imaginable that's running inside your house, and that can all run on different servers with your own spatial fabric. And that's extremely important because I think a lot of people, if you look at AltSpace and other platforms that went out of business, you kind of build for something and all of a sudden you lost all your assets and it's not compatible or interoperable with other platforms. And this is happening on a regular. And with the idea of open standards around a browser and spatial fabric, this no longer will happen because let's say if RP1 ceased to exist for whatever reason, if everything is built on the same standards, it's kind of like your website. Once you build your website, if one browser goes away, it will still work on all the other browsers. And you know that if you built your website to work for the World Wide Web, that any browser will be able to find your website and you never have to worry about that conflict again. And that's why an open metaverse is extremely important. And again, we're trying to have an open discussion about how do we get to an open metaverse with technologies that we're working on. And we're actually giving away to the community to make this all possible. And we're hopeful that we're going to invite individuals and companies that will say, hey, this makes sense. This will help bring the community together, but it'll also give you the freedom of the web or the internet. And for us, that's a really important step for us to realize the idea of an open metaverse. So let's go back to questions. So let's pitch girl. Oh, thank you so much. I appreciate the comment. She said it's exactly what I wanted to hear today, and that's exactly what I'm building out. So thank you, all of you. Listen, those compliments and comments are really important to the team because, again, if you really think about it, we could just go build RP1 and not think about these open standards and the bigger vision for the next spatial internet. And we're taking a lot of time to really push the idea of these open standards, and that's what the white paper is all about. And so your feedback and comments really help give us the energy to keep pushing down that road while we're also building out RP1. So I just want to say thank you so much for that. It really means a lot. Is there any other questions that people have that want to share? Oh, a raise of hands. I did say this on the thing. I said, what we'll do, I think it was about an hour. I'm happy to answer more questions if anyone has any. But if anyone raised their hand, if you would like to go inside of RP1 to basically experience what we believe is the first idea of an open metaverse through our demo. Again, we have a digital twin of our solar system. You'll be able to go see Earth 1-to-1 scale. We have a couple of sample sites on planet Earth that you can look at. And then you can actually go to space, and you're always connected. It's not like you're being teleported or somewhere. You can teleport to all these different places, but it's also all fully connected as well. And we'll all see each other all in one click. I mean, you basically put a URL in your VR headset. You can put it on your desktop, mobile phone as well. Obviously, I think in that order is probably the best experience, the least experience, just because you're fully immersed. But you'll be seamlessly be able to join us, and we can take you on a tour, and you can kind of see what an open metaverse could look like. You're welcome to. I know some people I recognize have been in our demo, but if you kind of raise your hand, if you were interested, I'm happy to give a link out, and we can all go in together. Roth, that's great. Anyone else would like to join? Okay, hold on, Roth. So perfect. So all right, so we will. I think we'll definitely open it up then for people to come up. You can, unless you want to come up to speak or ask a question, you can put your hand down. What we'll do is we'll put a link. The link is ama.rp1.com. Super simple. So ama ame.rp1.com. You can put that again in your, if you have a Quest, Quest 3 or MetaQuest 2, even a 1, you can just put that inside the MetaQuest browser, and you just put it in a URL, just like you would put like Nike.com. You just put ama.rp1.com in the browser, and then you'll instantly be able to go into the world, and then we'll all be able to see each other, speak with each other, and you guys can go on a full tour, and then we'll be inside there as well to answer any questions. Some people don't like asking questions in a big public forum, so you're happy to walk up to Dean or myself. I'm not sure Yinch will be able to join, but you'll be able to walk up to us, ask us any specific questions that are important to you. Dean actually put the link inside the chat, so it's super simple. Again, ama.rp1.com. And I just want to thank everyone for taking their time out of their day to come learn more about the white paper and what we're talking about. Again, we're hoping that this is a very large open discussion. We are working with the Metaverse Standards Forum, and we have a lot of open bodies that have reached out to us. So we're going to, really help those processes. But we'd love for you guys to join in any way or any capacity on the journey of towards an open metaverse. Let me see if there's any. Pixel Girl, yes, you're on our Discord, so you'll get updates when we have another demo. But I'll tell you right now, the team is working towards a global open demo where you'll be able to go to rp1.com, click one button, and go in world. And so you're no longer going to have to wait for times. It'll be open 24/7. We're hopefully going to have ideas like meeting rooms and spaces that you can go to. We're going to work with the open community that may want to design stuff for that open demo. And we'll be managing that all through our Discord and doing updates there. And so the goal is to get to an open demo within the next couple of months, and where we just never turn it off. So 24/7, you'll be able to go to RP1, you'll be able to go straight into the world, meet with any of your friends. You'll be able to also create an account, so you can actually add friends. You'll be able to chat with them from the website in world, and you can join them wherever they're at in world seamlessly. So we'll have a lot of amazing features that will make it super seamless. In fact, one of the nicest compliments we had at our last demo, that said the one powerful thing about RP1 that people are not understanding is that it is completely frictionless, meaning it is so easy for anyone to get in and not have to worry about, hey, do you have a Roblox account? Can you download that? Can you make an account? Can you figure out where to find my location? This is as simple as just going in world and instantly connecting with any of your friends, family members, work members, and you name it, and enjoy the power of the idea of the metaverse. And so we're super excited about getting to that global open demo. Some of the goals is just to make it more stable, more seamless, more tools, more ability to like mute, have different audio options. So we have a handful of things that we're going to get done for that open demo, and then we'll have our next phase, which is working on getting developers in to build content and be able to display that and share it with their communities. So that's kind of the roadmap over the next handful of months. But anyone, we're going to jump off. Unless you have any other questions, please feel free to raise your hand. We're going to jump in demo, and we can meet inside there. So ama.rp1.com.
I wanted to add, you can join on any device, so your PC, phone, and VR headset.
Perfect. All right, thank you, everybody. Appreciate it. Great AMA, and look forward to seeing you guys at other events, and hopefully we'll see you in the demo right now.
Thanks, John.
Thanks, Dean. Thanks, Inch. Thanks, NASA.
Thank you, everybody.
Thank you, everyone. I'll hang